All right, let's get started. So this is going to be our first video where we're going to write code, actually compile it, run it on the system. So what I have on the screen right now is I have what you are going to see when you log in to our VM portal. So you're going to see a virtual machine that has a blank desktop. There is a menu here that's out of the screen grab zone named Activities. When you click it, you're going to be able to go to this Show Application button, type terminal, all right, launch the terminal, and you're going to be getting something like this, okay? Then you can customize if you want the terminal to look and feel however you want, okay? So for example, I have a slightly bigger font here to allow me to take this video recording and allow you guys to see what I'm doing, okay? So I'm going to work on this terminal. This is going to be our main interface for the whole semester. So this is how you get the terminal. Now that we have it open, we can issue command line. So I already created using the mkdir command, okay? I already created some folders here. So I can go inside COP5227. I can go inside module 01, okay? If I wanted to create a new folder, I would say mkdir my new folder, okay? And there we go. The folder would appear, and I would use cd to go inside of it, and then cd dot dot to go back to the parent folder, go back inside module 1 maybe again, and etc. So you've seen the videos on navigating the file system. I'm not going to repeat all of that, okay? But bottom line is I'm going to remove that empty folder real quick. I have here a folder where I'm going to work for module 1, and I have already a file named hw.c, okay? Same kind of deal that we had in the previous lecture video. This is a hello world that's going to just display hi on the screen. So if I want to compile it, gcc, and I can do -o hw and then hw.c. In that case, it produces the executable hw, which I can run like was described in the previous slideshow, right? Or I can do just gcc hw.c, which I'm going to do most of the time. I don't specify the name of the executable. If I don't specify the name for an executable, by default it produces something called a.out, which I can run, and that's my executable, okay? So I'm going to get rid of hw, get rid of a.out, make a clean slate, okay? I have my file here, and I want to edit that file. So to edit the file, gedit space, the name of the file, and an ampersand symbol at the end. You hit enter, and there we go. Gedit is going to show up and open the file for you so you can modify it as you see fit. Okay? So this is literally the first thing that we do in most programming languages when we learn them, right? First thing you do is hello world. So a few comments here. In C, we use what is called the curly brace oriented syntax, right? Curly brace syntax. That means that whereas in Python, for example, you know that the printf belongs inside the main, generally because you would put a colon here, and then you would indent the printf under the int main, and that would mean this statement, and all the ones that are indented the same way that follow, okay, are under, for example, that function definition or something like that, okay? Well, in the C family of language, you don't use that. You use open curly brace, and you delimitate with an open and a closing curly brace the lines of code that you want to belong inside the main. So the same way when we have an if statement, okay, an empty if statement looks something like this. If, parentheses, and in C the parentheses are not optional, they are mandatory around your condition. Open curly brace, close curly brace, else, open curly brace, close curly brace, and you can still indent your code. Obviously, I recommend that you indent your code in the if and else part, but you see the limits of what has to be executed if the condition is true are given to you by the first set of opening, closing curly brace, and the limit of what has to be executed if the condition is false by the second set of curly brace. There are situations where curly braces are optional. That's going to be detailed in the textbook later on, okay? But for now, put your curly brace always, okay? It's like eat your vegetables. Let's put curly braces everywhere. Let's get used to handling and balancing out those curly braces because they are going to be coming handy a lot this semester. and let's embrace, this different type of programming language that doesn't show thing or organization of the code, just using indentation. It uses indentation plus those curly braces. Another thing that you are going to notice if you come from Python, semicolons. The semicolon is used to separate statement. Like, for example, if I want to do printf hi, and then which displays on the screen, the message hi, and then I want to display something like hi everyone, okay, everyone, I can put more than one statement in a line. And the reason I can do that is because I can separate my statement with a semicolon. So this is my first statement inside the main. This is my second statement. And then here's an if statement. I could put a semicolon here if I wanted. I don't have to because I use a curly brace. When you use a curly brace, the end of the statements list is at the end of the curly brace, right? But pretty much these are the two main differences for someone coming from Python. Okay, the use of curly brace and the use of semicolon. Now let's see what this would do if I was to run this. So I'm going to gcc hw.c. There we go. I'm going to run a.out. Hi, everyone. And that brings us to our first topic. What does printf do exactly? It displays a string, but some of you probably noticed that I have something weird here, \n. Well, if it's weird, let's get rid of it. I'm going to put a space here. Let's get rid of it just so that we can understand why we need it, when we need it, right? So recompile, a.out, hi, on the same line, everyone, and then on the same line, my prompt for the next command of the shell. So that \n sounds like it was allowing me to break the line in the output, go to the next line. And that's exactly what it is. \n stands for new line. So if I put a \n here, like right now, there we go. It's called an escape sequence, okay? So it's an escape sequence. It starts with a \, and it's followed by one character, and it means something special. So the printf doesn't try to display hi \n on the screen. It understands that when it meets a \n, that means that we have something special going on. In this case, we need to go to the next line. So here's what I displayed. hi, then printf was smart enough to say, hey, there's a \, so that means a special code, right? \n means go to the next line. That's what it did here, okay? Everyone is on a separate line. Then display EVERYONE exclamation marks, and then at the end, nothing. So I don't go to the next line, and when the program stops execution, the shell takes back control and starts displaying the prompt, right after the exclamation mark. If I don't like that, I can put a \n here too. This is what I had at the beginning, right? So let's try this. Let's recompile, rerun, and now it looks a lot better, right? All right, so those escape sequences, there are just a few that we are going to use. The \n, like very often you're going to see me use that, okay? And there is another one, \t, that I want you to get used to right now. So \n means new line, \t means tabulation. So you know what happens when you hit the tab key, like you're typing some text here, then you hit the tab key, it goes to the next tabulation. What is the next tabulation? Well, anytime you're using a text-based interface, whether it's a terminal or a text editor, you have to know that your line is kind of divided into 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. It's divided in columns, right? So I'm just putting dots here so we can visualize the column. If I type 1 and then tab, you see what happened? It went to column 1, 2, 3, 4, and it was ready to go on here. So let me try again. If I type, for example, Q, tab, it jumps to this, we call it the tabulation mark, okay? So every 4 characters, there is a tabulation mark. When you use Q plus a tab, it goes and positions you at the next tabulation mark. What if I type something like QW tab? Well, it would still go to the next tabulation mark on the line, the one that's located at character 4. So it would get us started typing the rest at character 5. Same thing for QWE. There we go, the tab makes me skip only one. QWER tab. This time something weird happens. What happened actually? Well, I was already with the R here. I had 4 characters, so I was already on this tabulation. So I'm not going to go backward or stay in place, right? If you want me to skip a tabulation, I'm going to skip 1, 2, 3, and I'm going to skip up to the next tabulation, which is going to turn out to be here, right? So that's going to be 5, 6, 7, 8, and I am writing on the 9th character. That's how tabulation works. It's something that we inherited from teletypes, from writing machines, pretty much. Okay, typing machines. This is very, very old, but it's still, applicable to terminals and to any sort of text interface, pretty much, that we're using nowadays. So what happens when I do hi \t? Well, it's going to display hi on the screen. Let me erase all that junk. It's going to display h hi, and then the \t is going to cause me to skip up to the next tabulation, where I'm going to display the next message, everyone, etc., for the exclamation mark, and then I'm going to go to the next line. Let's verify that this is indeed what's happening. So I want to comment out this thing. I don't want to erase it, but at the same time, I don't want the compiler to try to interpret it, because if I ask the compiler to compile my code right now, oops, wrong one, there we go, it's going to tell me, hey, I don't know what this means. Okay, this is a way of the compiler to tell me, when I come here and I see those ... this is not looking to me like proper C language. So to be able to comment out a whole section of code, /* at the beginning, */ at the end. Everything between the /* and the * is comment. And you cannot, to address the question that some of you might have, you cannot actually nest comments. Like I have a comment like that, open comment, close comment, inside another open and close comment. This is not allowed, this is not recommended, okay? So here I was able to comment out some part of the text file. You can see that the lines that are commented out appear in blue, so very well. I know that this is not going to be a problem for the compiler. The compiler will just ignore those lines. So gcc hw.c, here we are. So now I recompile my code, a.out, run it, hi, tabulation, everyone. So why so many spaces? Okay, here I have only 2 spaces. How many spaces are there? Well, tabulations are not necessarily every 4 spaces. In some terminals, they are going to be every 4 spaces. In some terminals, they are going to be every 8 spaces. Okay? So, and you can actually generally set the number of spaces that a tabulation counts for, like 4 space, 2 space, 3 space. I've seen editors that use 3 space, which is kind of a little odd number, weird number, no pun intended. But this is something that can be set up in your terminal. So when you do a \t, all you say is go to the next tabulation, pretty much. And whatever the tabulation is set at in your terminal is going to make a jump to that. So in our case, it's going to make a rather large jump here. Okay? So \n, \t. What if I want to display a / on the screen? Okay? For example, they want me to display a / on the screen. Okay, and I'm going to put a \n to go to the next line, and I don't need another printf. I'm just going to do everything in that one printf. So let's say that this is a message I want to display on the screen. Save that, come over here, compile, unknown escape sequence \040. So 040 is the code for a space, okay? So it's telling me, wait a minute, you put a \. So \ means something special, right? It's an escape sequence. And then what is a character that's supposed to tell me what I need to do? It's a space. I don't know what to do with a \ space. It's not an escape sequence that I know. It's not \n, it's not \t. It's none of the ones that are listed in the textbook either. So what's going on here? Well, if I want to display a single \, I need to find a way to tell printf, you know that \ that I typed here? You should not interpret it as the beginning of an escape sequence. There's going to be nothing behind it that encodes, that I want to do a \n or \t. None of the letter that you expect. So I just want you to look at it as a simple \ that has no special meaning and just display it on the screen. Well, guess how we do that? \. Backslash means escape sequence. The escape sequence that has a character backslash right after the original backslash just means I want you to display one backslash on the screen. And I have to type two backslashes to display one on the screen, absolutely. So let's compile, run, there we go. What if I wanted to display two of them? Then I would have to type four of them, okay? This first backslash means start of an escape sequence. Okay, what is the code? Backslash. So, okay, you just want me to display a backslash. Done. Start of an escape sequence. What is the code? Backslash. Okay, so you just want me to display another backslash, and so on and so forth. Okay, so this is something that we're going to use on and off occasionally. So it's good to know what the backslash does. Okay. Similarly, if I wanted to say, you know, they want me to display and put display between double quotes, do the air quote thing, right? You see that even as soon as I type double quotes inside the string, it doesn't work anymore. Okay, the compiler, the syntax coloring is telling me, oh, something is wrong with display. Let me try to compile this. It tells me I expected something different before display. I expected you to actually close the parentheses. Why? Well, because this is the start of my string, okay? These are the character in my string, and oh, here's another double quote, so that must be the end of my string. This is how the compiler understands this situation here. But what I meant is I want just the character double quote. Okay, don't interpret it as meaning the end of the string that I'm currently typing. Just interpret it as meaning a basic double quote without special, meaning in terms of syntax. Well, we know how to remove the special meaning of a single character. We precede it with a backslash. So if I put backslash double quote, that's yet another escape sequence. So we know backslash n, backslash t, backslash, and backslash double quote now. And what does it mean? It means replace this by just a single double quote. And you see that now the syntax coloring seems to be okay with that. Let's see if the compiler is happy. I'm going to compile this. It is happy. It runs. And when it displays a message, it displays double quotes. Okay? So we started with the little bit of syntax that are different from Python. Now we covered pretty much, how to do basic displaying on the screen of messages, including some weird stuff with escape sequences. Another thing that is really new compared to Python is that we cannot just use variable nilly-willy here. I cannot write x equal 42. Let's see what happens if I do x equal 42, okay? And then I want to display, for example, here, there we go. I want to display the value of x, okay? This is something we can do in other programming language, including Python. In C, it's going to tell you error, x isn't declared. This is the first time I see you use x in this function on line 4, character 2 from the left, okay, for counting the tab. So the first line where I use x, is line 4. Well, you cannot use a variable without declaring it. So what does it mean to declare a variable? It means that in C, before you can actually assign a value to x, and by the way, notice a semicolon, we are going to have a ton of them in our program. This means this is the end of the statement. This means I could do printf right on the same line after, okay? I'm going to leave it like this so that you get used to the difference between the two languages, okay? But if I want, going back to our original problem, if I want to use the variable x, I must, before to use it, declare it, okay? And generally, it's good practice when you declare a variable to also initialize it, which means put an initial value into it just as a placeholder until you know better what to do with it and what value you want to really assign to it. So how do we declare a variable? You put the name of the variable equal the initial value you want to put inside of it. Wait a minute, this is like an assignment. Well, yeah, there's a piece missing, okay? You need to type before the name of the variable, you need to type the name of a data type that the C language knows. So there are different data types. Int is your typical smallish integer value. Okay, it goes up to, I don't remember, 32,000, something like that. I don't remember. It's encoded on 30-bit if I'm correct. So you can go only as far in terms of the values that you can store in an int. It occupies just a smallish amount of memory, and it encodes in binary an integer value. If you need a larger number, we're talking about 9, 10 digits, values, then you would use long. So I can declare a variable long, y. So variable name is y, the data type is long. And C is going to always keep track for each variable that you declare of the name, of the data type of the variable, okay, what it's supposed to contain, and how much memory you need to store what it's supposed to contain, and the current value of the variable, okay, what value is stored inside the variable. So variables work really like in Python or other programming language, but we need to declare them before we can use them. If I have a declaration of a variable, now I can go back to my compiler, and the compiler is going to be not quite so happy yet, but we're going to work on it, okay? So it's complaining here about the printf. So you know what? I want to comment out the printf for now. We're just focusing on declaring and using variable, assigning values and stuff like that. So I could comment it out like this. But you know what? When you want to comment out just one line, you can put // and everything from the double / to the end of the line is considered a comment and ignored by the compiler. So that makes it very easy to just remove, like the second half of a line or something like that. Let's try to compile again. Now it's compiling better. Okay, if I run it, it's not going to do anything exciting because it just declares two variables, x and y, put zeros in them, and then change its mind and put a 42 in the variable x. But we don't display anything on the screen yet. So let's go back to this. Why is printf not letting me display anything? Well, it's because printf has a very, I was going to say very peculiar syntax. Well, it has a syntax. There are rules on how to use printf, right? So the common way that you are going to use printf is going to be a little bit more involved than what we have been doing until now, which was just printf, double quote, a message, double quote, and then close the parentheses, close the semicolon, okay? The general use case for printf is to have a first string separated with a comma by something, which is what we want to display. So if I wanted to display hi, I would put it here. If I want to display x, I would put it here, okay? And that first string, this is a string that's going to allow us to tell printf, this is how I want you to display the information. So comma x means I want to display the value of x. But how do you want it displayed? So we have to say, for example, I want to display value of x is followed by a space. Then I want to insert the value of x right there, and then finish with a \n, meaning go to the next line. How do I mention that I want to insert the value of x, which is here, okay? Right at the spot in the string. I need a marker. I need a marker inside this formatting string that tells me how things are going to be displayed on the screen. So the way that you specify a marker is by using the %sign, okay? And followed by a code. Yeah, we like to use code in C, okay? There's code for reading values, code for displaying values, and so on and so forth. So we escape sequences and the like. What is a code to display a variable? Well, it depends on the data type. So let me rephrase. What is a code to display a variable of data type int? %d, of course. You are going to have to memorize those, okay? But don't worry, they are also in a table, in a nifty table, in the textbook. This first chapter 2, is not going to give you all the codes for int, long, etc. We are just going to work with int for now, but as we introduce more of the data types that the C language can utilize, we are going to also let you know what are the code that you need to use when you want to display a variable value of that data type, okay? So here, a %d, and then I can put my \n right after, okay? It tells me, okay, I want you to display value space of space x space is space, and then I'm going to give you a value. So this %d is going to be filled up with the value of x. Then I want you to display a \n, go to the next line, and then I could keep writing, value of y is %d and backslash n. So what happens now? I have two markers, two %ds that mean I want you to insert right here, okay, and right here. I want you to insert int values. The first one, the first %d, the value is going to be given to you right here, comma x. What about the second %d? Well, I need one more value, so comma y, okay? Or I could put comma, you know, and the value directly here. I put the value separated by comma. I put all the values that are going to be used to fill in the blanks here, fill in all of the tags, % something that have been used in the formatting string to specify we're going to insert a value right there. So let's try like this, okay? Let's not just use x and 23, or I could say even 23 plus 2, an expression, an arithmetic expression is going to get evaluated, and the result will be used to display here in the %d, in the second %d. So let's save this, let's compile it, and let's see what comes as an output, okay? Value of x is 42, go to the next line. Value of y is 25, go to the next line. Okay, so 42, yes, this is what's inside of x, bingo. And then where is the 25 coming from? It's 23 plus 2, no problem. Okay, so you can put arithmetic expression here, you can put the name of a variable, you could put, for example, 23 plus 2 plus y minus x, so you could put an arithmetic expression that contains actually variables, no problem there. Well, apparently there's a little bit of a problem. Expect argument of type int, but the argument 3 was of type long int. Oh, yes. Okay, let me change that. I'm going to say y is an int too, because otherwise the C compiler realized that 23, yeah, it looks like an int. 2 looks like an int. X, it's an int. It's been declared as an int. But the variable y was declared as a long. What happened when you add up numbers of different data types? Well, even if the different data type each represent, you know, an integer value, an int is decimal in memory, a long is double the size, you know, so it can store numbers with a wider range. So when you are in the same formula, in the same arithmetic expression, when you are adding a long value and an int value, so a long variable, an int variable, then C says, because one of the variable is this big, potentially it contains a big number, so I'm going to say that the entire result of this arithmetic expression is going to be of data type long. And that's what the compiler does, and that's what we are going to train all of you to do when you write code. Keep track of the data types, okay? You declare your variable, you say x is an int, y is a long, it has consequences, okay? Arithmetic expression are not only going to yield values, they are going to also yield values of a specific data type. So in that case, the result was a long, and then the compiler was telling me, you know what, %d is only used to display int value. If you want to display a long value, you need to use something else. So for example, let me go back and put back long for y. I'm going to put a big value in y. There we go, that should be enough. And what I'm going to say now is I'm going to say I don't want to display just an int. I want to display a long decimal number. Okay, D stands for decimal. So pretty much, I don't want to display an int data type value. I want to display a long data type value. Let's go back here. Now we're going to try to get the compiler to accept that. It's still complaining about the first %d. Hold on. Yeah, no. It's complaining because I didn't save my file. I was like, are you complaining about another %d? No, it's not. There we go. It's working. And then when I run it, it's going to display the values normally. Okay? So we're going to come back on that. I'm anticipating a little bit on the next module, just giving you a teaser, okay? But we are going to re-explore, you know, arithmetic expression in depth and typecasting conversion. This is going to be covered in the reading assignment. Don't worry. Right now, I'm just giving you an idea of the fact that when you add and subtract and multiply and divide variables by one another, it's not just the result that matters. The data type of each of the operands matters, and when you recombine them in the formula, then the formula also tells you what the data type of the end result will be. And that matters for scientific calculation. That matters also for things like, for example, you just told me you wanted to printf a %d. If the result here turns out to be of data type long, you cannot use %d. You have to use %ld, right? And if I go back here and I say my y, you know what? Afterward, I change my mind and I'm going to say it's just a regular int number. Then I won't need anymore that %ld. I can go back to a %d. Okay. All right. So data types. We need to declare the variable, specify the data type, then the compiler keeps track. Every time you use that variable, it keeps thinking about the data type of the variable, what's going to be the outcome of using that data type, in that context. And then the markers that we use, for format specifier in Printf change depending on the data type. So we can declare a variable, we can assign a value to it. We can do some very basic arithmetic, just using, what you learn in the prerequisite, what you learn to do in Python. It works approximately the same. Okay, we're going to build up on the differences as we go further into the chapters of the textbook. But like you can see that 20 plus 2 plus y minus x, I just use a plus minus. The multiplied symbol is a star. The divided symbol is a slash, forward slash. So all of that should seem familiar, right? It's the same thing in Python. And there are other operators that we're going to introduce later again, but we're just at the beginning here. So we know how to assign different value, compute new value, reassign them to the variable. We know how to display the variable. How about reading a value? Okay. How about if I wanted, instead of assigning x to the value 42, I wanted to say to the user, enter a value for x, colon. Okay. And then I want them to give me a value for x. So I want to do a scanf. So printf is to print on the screen. Scanf is to scan a value or some text sometimes from the keyboard. And scanf has kind of the same logic than printf so far that it is going to have a formatting string. The formatting string comes first, okay, and it's going to allow me to say I want to read from the keyboard an int value. So how do you specify an int value in scanf? %d. And then is there like comma and more argument coming after? Yes. After the comma, you are going to specify for that %d, and generally we're going to use only one marker like that in the scanf string, whereas we use very often multiple markers in a printf string. So I want to read an int. Where do you want to store it? Well, I would like to store it in the variable x. Well, that's not good enough. You need to say inside the variable x. So that symbol, the ampersand symbol, shift 7 on your keyboard, is going to say pretty much, I want to store the result inside the variable, which name follows immediately the ampersand. And that's just a very peculiar thing to write, right? This is the syntax of scanf. Don't worry. For now, I want you to learn it as a recipe, but very, very soon we are going to introduce pointers, and by the middle of the semester, not the end of the semester, by the middle of the semester, you are going to know the full story about why we have to use that little symbol, and it's going to make sense. But for now, let's not go and try to explain pointers in the very first coding videos of this course. For now, just accept it as every time you want to scan into a variable, if you want to scan into y, so you say into y, okay? Into x, and the into is represented by this ampersand. This is a nice trick to remember it, okay, until we have the full explanation available for you. So now I'm allowing the user to specify the value of x. So I can go ahead and say compile, run it, enter a value of x. And when the scanf executes, it waits. It waits for me to type something and hit the enter key. So if I say the value of x is, for example, I don't know, 999 and 5999, there we go, enter. It's going to store that inside the variable x, and the next time on line 8 of my code, when I display the value inside of x, it's going to display 9,999. Then when I do 23 plus 2 plus y minus x, then it's going to come around to minus 8,740, which is still an int value. Okay, int can be positive, negative, or 0. they just have a fixed range. And if you want to exceed that range, then you use a long data type instead, which is also an integer, but with more possible values. So what's left to cover in this chapter 2? Well, what's left to cover is we talked about arithmetic expression, right? Like 23 plus 2 plus y minus x. There's another type of expression that are available in C, also available in Java, Python, any programming language. It's called Boolean expression. So an arithmetic expression is an expression that when you evaluate it, yields a number. Right? For example, we have been using integers here, right? Int. So all the operands were of data type int. We add them, subtract them, multiply them, blah, blah, blah. What we get at the end is a result that is of data type int. There is another type of expression. This other type of expression is called Boolean expression because the value that it yields are either true or false. There's no other possibilities, okay? So that's called the Boolean value, true, false. So we use them often in if statements. I'm going to introduce an empty if statement here. There we go. There are holes here where I can feed in the code that I want to do when the condition is true and the code I want to do when the condition is false. My condition goes nicely between those parentheses here. And I'm going to say things such as, for example, if x is lesser than 0, so that would be a Boolean expression. A very simple one, but it's a Boolean expression. Any comparison between two expressions or between two variables or between a variable and an expression, like for example here we compare x to 0, right? All of those are good, solid, perfectly formed Boolean expression. So I just use the lesser than operator here and I say if x is lesser than 0, printf x is negative, okay? And else printf. So I don't know if it's positive or 0, to be honest. So I'm going to say x is positive, but it's kind of a bit of a lie, except if you consider that 0 is positive, okay? So now, this is an if statement like you've seen in Python, but we have those extra parentheses, those extra curly brace, etc. We say that after reading a value for x from the user, we compare x to 0. If it's true, if this expression is true, I execute everything that comes between those first pair of curly braces. Else, if the condition is false, so x is greater than 0, for example, or equal to 0, then I execute what comes between that second pair of curly braces. Okay, let's run it, just to see it in action. Compile, run, enter a value for x, minus 123. My x is negative. Oh, I could use a \n somewhere, so you know what? Just so that the shell doesn't prompt me, right after my output. I'm going to put a \n here after the if-else statement. So it's going to display no matter which branch of the if or else I executed. Let's recompile this, run it again. Enter a value for x, minus 123. X is negative. Let's run it again. Enter a value for x. X is positive with 0. I don't like that. Enter another value, 123. X is positive. That one I like. So let's fix our program. When this condition is false, okay, I go and execute everything that is inside the curly brace pair that correspond to the else. But I don't know yet if x is 0 or x is actually positive. So I can go ahead and say if x is greater than 0, then I can display x is positive, else, and I make sure that I open and close my curly brace. Every time I open a curly brace, I immediately close it so that I don't forget to close it, okay? And I indent my code. Keep your code very readable, okay? Printf, x is null. So x is 0, x is null. Some people are going to say x is nil, okay? Doesn't matter. Let's say x is actually 0. And I'm going to compile this, run it. Again, 123, that's positive. Minus 123, that's negative. 0, that's 0. All right. So we can nest the if-else statement. You just have to make sure that your curly braces are matching. And you notice that when I put with gedit, when I put my cursor right before curly brace, it shows me, it highlights where the curly brace is closed. Okay, if you forget to close the curly brace, like here, welcome to what we affectionately call in the introductory programming class, curly brace is hell. Okay, because now the compiler is telling you, I don't know what you're saying. When I reach line 18, I have a feeling that something is missing. Yes, but it was missing on line 15, and the compiler is not smart enough to decide this and let you know, right? So this is why it's important that you don't forget to pair correctly your curly brace to indent your code. If you write your code sloppy, you are going to forget curly brace. And then I've seen students spend 15 minutes trying to figure out, where they forgot their curly brace. And it's a total waste of time, obviously, especially during an exam where you have time, to come up with a solution that just adds to your stress and that can completely tilt you, okay? So be careful about that. So that's it. Be careful about those curly brace. We have a series of 2 if-else statements. What else could we use here to do to come up with Boolean expression? Well, we have only 6 choices. Lesser than, greater than. There is also, I'm going to write them here. Okay, I'm going to put another comment. So the Boolean comparison operator are lesser than, lesser equal without space in between, greater than, greater equal. How do you test if 2 things are equal? A double set of equal signs. Why do we use 2 equals? Because a single equal is already meaning something. A single equal is what we use for assigning a value to a variable. The variable name is on the left of the equal. The value is an expression or like a value that we directly wrote, like 1, 2, 3, 4, right? Or like another variable or whatever. And this value is assigned to the variable on the left. So we cannot use equal, so we have to use something different. The convention was to say we are going to use equal. And how do I write that something is different? Like if x is different than 0, okay? Well, to write different, I'm going to use exclamation mark equal, okay? So there's no trick to that. You just need to learn those. There are 6 different operators, comparison operator that are used to compare values, like int values, for example, in the C language. All right, with this, we have a sort of a condensed overview of what is presented in chapter 2 of the textbook. As with all of those videos, remember, the lecture video is just there to give you an overview, to introduce you as gently as possible to the concept that are in the chapter. Then, now that you are done listening to this video, go and grab your textbook, open it up for chapter 1 and chapter 2, which are the 2 chapters that are assigned for this first module, and read the content of the chapter. There are going to be additional details that are going to be conveyed to you. Then use the practice quiz to make sure that you didn't miss any detail. And when you are ready, take the graded quiz, and then you'll get an evaluation of how well you understood the basic concept. Okay? And then when you're ready, move on to the apprenticeship exercise, move on to the practice assignment. These are going to prepare you for the next intermediary exam, and so on and so forth. I already went over that in the first video that you watched in this module. But I want to reinstate it because we are just getting used to this routine. After 1 week of this, second week of this maybe for some, you're all going to feel pretty comfortable and familiar with the routine. Okay, just be mindful during the first and second week that you don't forget anything. All right. Thank you so much for your attention, for watching this video to the end, and I'll see you in the next video.